All right, here we have a spring mass system with a mass of 2 and a spring constant of 50 on a frictionless surface. Then we give me some information about initial conditions, and then we apply a force with this sine and cosine of 5t. I want to find an equation that tells me what happens. So the first thing I'm going to do is set up the differential equation. You should know that mx double prime plus cx prime plus kx is equal to f of t. In this case, we've got m equal to 2. This right here is the k value, and the c value, which is a damper, is not something that we have to worry about here. So I get 2x double prime plus 50x is equal to, and this is where the f of t, the force that's being applied to the system, comes into play. So that gives me 3 sine of 5t minus 2 cosine of 5. The first thing we're going to do is find xc. xc, we just do 2x double prime plus 50x equals 0. I can divide that by 2. X double prime plus 25x equals 0. You should see that that gives us an r squared equation of r squared plus 25 equals 0. If I move that over and square root, I get the square root of a negative number. So that gives me r equals plus or minus 5i. From there, we can use Euler's formula to get to the line xc is equal to c1 sine of 5t plus c2 cosine of 5t. You could flip them the other way around if you want. It's arbitrary. It doesn't matter. You can have c1 cosine and c2 sine. I'm going to roll with it like this for this one. So this becomes a problem because the force that's being applied here, sine of 5t and cosine of 5t, matches the forces or the natural frequency of the spring. The rate at which the spring wants to oscillate is the same as the rate that the force is being applied. As you can imagine, that makes the forces or the oscillations amplify upon themselves and gives me what's called resonance. So I take a special xc or xp to be able to solve that. I want to use xp equal to capital A, what am I going to do? Sine of 5t plus capital B cosine of 5t. But that's not going to work. I know that those run through this equation here are going to give me 0 because they're part of the solution. So instead, I tack a t onto both terms. So I take xp equal to at sine of 5t plus bt cosine of 5t. And then from there, I can figure out what my a's and my b's are the same way we do with all of these equations.